Okay? And how many of you guys have actually done any screen design or anything like that and worked with it?
I have.
Okay.
Designing a web page.
Okay.
HTML.
So,
Yeah.
the very first thing that happens is I say, okay, I'm gonna make this a really simple one. On my screen, I'm gonna put a great big button. And I'm gonna call it Push Me. So I got a Push Me button on my thing. So I told the browser, render a page and put this button on here. And I could put all kinds of parameters, make rounded edges, make the font this, I could do all those kinds of things. So I commanded the browser to do that, all right? Now the browser did a whole bunch of additional things that maybe not are 100% obvious to you. It went over here and it says, for a button, I'm also going to put all of these events. I'm going to build these events. I'm going to have the hover over the push me button. I'm going to have the click, they actually clicked the push me button event. I'm going to have the, I don't know what other things are associated with buttons, I'm not an expert. But there's all these events that can happen as a result of having this button. And in the browser, who is tracking you moving your mouse, recognizes that, oh, I'm hovering over that. Now I'm pushing it. It's the one that it created a whole bunch of events in its container memory associated with you just defining that push me button. So now I came back and I say, oh, and here's a text field. What are the events do you think that it automatically creates?
3 days.
Probably hover.
Yeah. There's probably like a few clicks inside of it too.
Yeah.
Probably
What
starts
happens if
writing.
you type after you have it selected?
There's an event that if you're actually typing something, what else?
If you wanna submit it. maybe.
What's submit?
There's no submit on a text box.
What about I leave it? There's an event where I'm in here, type, and then I go someplace else. There was an event if I left the box. Okay? So it creates all these events for you automatically. And there's a convention in browsers for naming of the events. Okay? On the push of the push me button, I can actually name that event. So what you end up doing is you end up writing code that says on the hover over push me button event, this is what I want you to do. And you can actually put code in to the browser. You can send to the browser JavaScript code that says, when that event occurs, this is the piece of code I want you to execute. That make sense? It's completely event-driven. When they actually push it, this is the piece of code that I want you to do. What if you don't put any code in? The hover over thing. Nothing happens. So in browsers, we become very used to the idea of, if I tell the browser about some object down here, it automatically created a series of events, which if I'm an expert, I know what those events are, and then I can associate code with each of those. So if you look at the piece of code that gets sent to the browser, it's not sequential in any way. It's here's a set of things that happens when you render the page, and then here's just a bunch of chunks of code that I want associated with these events that I want you to execute when you do that. Does that make sense? You buy off on that? All right, so what's Node.js? Node.js is this great container that's kind of like a browser, but for the server. So what happens? It says, you put your Node code in here, and by the way, I'm the guy that's keeping secrets. You never see these. You never see these event things. I'm the guy over here that keeps track of events for you, Node.js, and you can associate pieces of code with events. So in the browser world, it makes perfect sense to us what kind of events happen. Hover over a button, push a button, etc., etc. What are the kind of events that happen in Node.js?
Are those the GET requests?
Okay.
Well,
What was that? What was that event?
like,
Do you have to define your own events kind of thing?
Less intuitive, but you're kind of defining your own, right? So if you say, oh, I'm going to go out and read something from a database, and you include the Node library for it it created an event of, that maybe looks something like, I don't know, because one of the mistakes I think Node made is it didn't expose them to us. Return from BB Mongo event. There's an event out there that looks something like that. Now you wrote your code and you don't really know that's the name of it. You said, write my code, I'm going out to the event. And then said, okay, great, I'm gonna go out to the database and I'm gonna create this event, return from the database, and I'm gonna watch, and when it comes back, I'm gonna, oh, that event got satisfied and I know what I'm gonna do. And then if you wanna execute code on that event, I'll let you. Right? And so then there may be some code associated with that. Pull back up the node we were just looking at. Okay? We're gonna play computer. We're gonna see if I'm totally wrong.
Oh, did I press enter? I did.
Always.
Press enter and some shit.
All right, let's look at the scatter gather code. Scroll up to it. Oh, now we don't need to roll this one. Okay, scroll to the scatter gather code.
Oh, no, that was good. That's good, that's good. This one?
Okay, so right now, right in here, it says scatter request. What's it really doing?
It's or publishing or raising an event.
It's publishing an event to the SNS topic right here. And one of the possible events that could be created is I get something in return that's associated with that guy, right? So what it literally did is it said, I'm running along in my code and I'm gonna write something out to SNS and I'm done. Oh, but first I'm gonna go over here to the event table and I'm gonna say, my event is return from SNS on public port that looks like X. When I get something back on the public port that looks like X, I want it to do this. And what is the this?
Must have been your battery.
Am I knocking this out?
No, it's
No, her
bottom
battery
floor.
just died.
On the left side.
Well, do you have your power cable?
I was gonna go get it.
Okay.
I'm fast.
And what is the code that looks like when it returns from, when the public port gets something, whatever? What does the code look like? Got together. Then, function results.
Right, it's a callback function.
It's the piece of code right there.
Right.
It's the inline callback. Now, literally, it's not literally waiting. It's not running sequentially, and at this particular point, pausing and blocking and waiting. It's not doing blocking kind of code that we're used to thinking of in sequential scripting languages. It's saying, I'm done. I'm out of here. But by the way, I set this up here so that when this thing comes back, then I'm going to execute this piece of code right here. That make sense? It's a completely different animal than a sequential scripting language. So that piece of node code literally said, I execute it right here, I go off to this thing, oh, by the way, I'm gonna set up this event that's looking for something, and when it executes, it'll execute that way. And JavaScript lets you put it in line so it looks like it's executing sequentially and waiting, but it ain't blocking. It's not doing that. Does that make sense? So Node is this very sophisticated environment that allows you to set up these events that it's looking for.
Yeah, and it's great because it's taken what we've learned from the browser environment and serverized it.
And it's truly an event-driven
Yeah.
programming language, not a sequential scripting language.
And that's probably the biggest challenge that procedural programmers are having as they move over to Node.js, is trying to figure out, wait a second, I want it to be consecutive, I want it to be
And I want this debugger,
synchronous.
I want this debugger that sits there and pauses and waits before it goes to the next line
Yeah.
of code.
Yeah,
It ain't how it doesn't work that way. So as your understanding increases, it would be good for you to get to James and say, okay, hey James, when you wrote this scatter gather function, what does the event look like? And what are you doing so that when the message comes back in, you can correlate it and understand it? Remember I told you about that correlation ID? He's doing it for you in the background. If you understand his function and that he's raising, it will give you a better understanding of what's going on.
So James is assigning a correlation ID in the background?
If he's not, how in the world does this event get back to that spot in the code? He's not doing something. Understanding what he's doing is going to help. Now, is he doing a full-blown correlation one so that a bunch of messages can be all flying at the same time? I don't know. That's the understanding that you need to get, but I bet you he's got it working pretty slick. But when he put out this event marker, when that message came in on the public port, it was able to match it up, I'm assuming, because if this thing was running and I had 5 of these out, return one port, and this one's Y, and this one's Z, and this one's Z2, as these messages come back in, he has to get it to the right event and make it execute. Maybe. But does that make sense?
Mhm.
So really what Node.js is doing is it's this great big event engine, and when you get to a point where it says callback, that means I'm done. Now, one of the cool things about Node.js for computer science guys who are interested in understanding this is Node.js is not multi-threaded. It is a single-threaded environment because it works this way. Now let me explain what I mean by that. In a multi-threaded, in a traditional scripting language, Python, or any number of compiled languages, this is literally the way it would work. I would have some process that starts up, and the process is running along doing sequential code, and then it says, hey, I'm gonna make an HTTP call. I'm gonna call a web service. It's gonna call a web service. And I'm going to block. I'm going to wait for the return. And then I'm going to go on processing the rest of my code. That makes kind of sense to us as humans, right? All right, so the computer starts up. I only have one processor on my computer. It runs down, I make my call to my web service, and I'm now blocking. The computer's sitting there waiting. Right? A second for the return. Is that fair? Do you need this room, Peter?
No,
Oh.
we normally have it scheduled, but we can call anywhere. We'll just go to another room.
Oh,
We're fine.
we can leave. We're in the extra part. We can go back at our desks and do
Don't
this.
do that, don't do that.
Because I have one part of my desk, serious.
Yeah, no, we're okay now.
Okay, all right, so that would make, does that make sense to you? That's what's called a blocking technology. It says, I can continue on with my code until I get my return. So I've got my computer running, and it does that return, and now it sits there for a second, right? That's how computers work, correct? No. If I had a piece of server code that was waiting every time I do that, I'd never get anything done. Because the next thing is it comes down here and it says, I need to read something from the database. Well, guess what? Reading from the database is another blocking thing, and I'm waiting for the return. And if I sat there and waited, could you imagine if our student registration system worked that way? Okay, I need something for the database, so I sit and wait every time. That isn't how computers work. So what do? Well, what they do is on my computer, is I have, in our student registration system, I have literally hundreds of processes, thousands of processes that I'm capable of starting up. So when I hit this point and I'm waiting for something, it's multi-threaded, my computer jumps over and it starts running on my next request. Oh, now, Alyssa, I'm giving Alyssa her answer, oh, but I'm waiting for this web service, so now I'm gonna jump over to this other process, swap it out, I'm gonna come down here, I'm now doing this for Trevor, and I get down to, oh, I need to get something from the database. Well, now I'm blocking and waiting, so I go to sleep, oh, let's load in Spencer's, and now he runs his piece, and it's got all these threads that it's working. And then it comes back eventually and it says, oh, when this came back, then I'll load this one back into memory and I'll keep executing down. Oh, no, I've got this one, I'll load this into memory and keep executing down. Does that make sense? So the environment has multiple processes, it's multi-threaded, and it's running along working that way. Okay? And that's the traditional environment we've had since the mainframe, right? Works pretty well. I mean, we're running our entire student registration system on that. So does that make sense? That's what we call kind of a blocking technology. Python, a lot of your scripts, that's how they function. So you have to have a whole bunch of processes all running to make the thing work efficiently. Yes?
So when it flips back to Alyssa, does it do that just when it receives the return? Or when it gets stuck on Spencer again, it just like checks at that time?
Usually what things do is you very rarely have a priority interrupt. So when this one gets stuck, it goes back and says, what's the next thing on my queue? And if Alyssa's answer came in, eventually hers will come up on the queue and it'll swap hers back in and do it.
Cool.
Now you can prioritize your processes. So if Alyssa's had a higher, these probably all, for all the students, they all have the same priority, so they're just taking it off the queue and doing it. So one of the problems that we do see in our systems is it starts getting gummed up, and you never get back to your thing, right? Okay, that's, I don't know that you can really solve that any way you go about it, okay? But that's how most of our processes work, and if you're writing Python, that's right. That is not how Node.js works. Node.js is a completely different animal. Remember, I said it's single-threaded. There's one process running. So it doesn't depend on the operating system and flipping around memory to do this. It says, I've got my own event queue, and when I see events come back in, I'm not going back to that spot in code to execute. I'm running off a whole new piece of code. I just go to the spot in code that you want. Pass the parameters in, off we go. So it does not work this way. It doesn't thrash back and forth, loading contexts in and out of memory. It's just taking the next event and saying that piece of code, boom, off we go. Okay, next event, off we go. So when people look at it, Node.js, for a lot of the business problems people have, where they're having to read databases and stuff like that, performs like, it's just like magical. It is so much faster. But you have to understand it's written on a completely different thing. Instead of being sequential like this with blocking, stop, swap out memory, it's just taking the next event and execute, and when it gets to the point where puts up the thing in the event queue, boom, done. It's not swapping things back and forth, it's just taking stuff and going. It's therefore very incumbent when you write your code that you'll see a lot of times all of this stuff in here, it's passing its context as parameters back and forth, not reloading them in and out of memory. It's a completely different way of thinking, okay? And I think it's kind of cool. So, does that make sense?
Yep.
All right.
So with Node.js, parameters are often passed back and forth, but with this, you have to reload everything. Because Alyssa's run that process and now has to figure
Yeah,
out,
and
oh
it-
yeah,
It
I've
has
run
to
that
come back and
process.
restore the context.
Yeah, so what
So
it
you
does is when
swap
it
it
does
around.
the context switch from
Mhm.
Alyssa's process to Trevor's, it's gonna take all of the things that's in memory and all of the registers and everything. It's gonna take that whole thing and move it out to disk. And then it's gonna take what was on disk in Trevor's stuff and start running that.
Wow.
And so that context switching is very expensive.
And especially if you've got a lot of database and things, you end up looking at, like, our boxes, we end up having to scale up many more boxes, because what percentage of the work is actually just context switching? It goes over 50% pretty fast. So what the machine is doing is just context
Swapping
switching
stuff
back
in
and
and
forth,
out.
back and forth. But that's why when you look at these, it's kind of scroll back up here. No, scroll this, let's see, where did I want to show it? Oh, here. Yeah, is this a good one? No, go down here, excuse me. So when you look at this, you end up with these situations of, I do this thing, and then function, and I'm having to repeat all of these parameters. It's like, why don't you know it? It was just right up here. It's because it wasn't. In the code, it's not right there. It's not available anymore. It's completely gone. Anything that's going to be available from this piece of code on here has to get passed in. It's not context switching, it's passing them to get it started each time. Does that make sense? So I don't have multiple versions of the code that I'm switching back and forth. I have one version of the code, you better pass in everything I need, I execute on it, I don't know anything about context, I execute on what you gave me. If I have to set up an event, and I'm gone. Very, very fast. And slightly different. And so that's why, as you start looking at this Java code, this JavaScript code, you're gonna start understanding. Sometimes it seems verbose, okay, what's happening? Oh, I actually have a callback here. This is a function that's gonna go off to someplace else, and so now, and this is how what I need to get passed across to reestablish context and start running again. Because it hasn't got it any other way if I don't pass it to it. So you start to see, and you're gonna see these, and in some ways I almost wish with JavaScript they would have called it out instead of doing these inline functions. Oh, at this particular point, I'm creating an event off in this Node.js event table, and here's what it needs, that piece of code to take off and go, and it's gonna run and do its thing, and done. And so you'll see these lines of code where you get, callback, 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 and it looks like it's one sequential code to help you visualize it. It's not, it's 4 distinct chunks of code that are running. Okay? Does that help a little bit understanding what kind of an animal you're working with here? I like it because I want you guys to think event-driven, but that's really how it works. And if you go back, any of you who've done web design, or you go back and look at the web code, the stuff that's getting passed to the browser, all of a sudden it's like, oh, that makes sense. All it is it's telling the browser it's at the start of the point, set up all these controls and functions, and then it's just giving chunks of code to do on the events against those things. That's all it ever does. Okay? That makes some little sense. Now, with that idea for some of you guys that are a little further, so what in the flip is a promise?
That's what I was gonna ask right now.
It's how you make this asynchronous stuff synchronous.
In my opinion, I don't know that I really understand it as well as James. All it is I get to name my event. I'm just defining an event for the event table, and I'm saying, when these conditions happen, and here's the name of it. Right? I've made explicit what that event is. You know what a promise is? And so it says, when all of these things happen, execute this piece of code.
So is
Right.
is it saying that when a combination of events are completed, then do this?
Yeah, you can make those pretty complex, can't you? A promise?
Yeah?
You could make a lot of situations that
I can even make a promise, when these other promises all get completed, then do me.
Yeah.
I'm getting to name my own events and put them in Node.js's event table. I think that's all a promise is. What else could it be? And it says, and when that happens, execute this chunk of code.
Why do they call it a promise then? Is it just like, it's committed?
I don't know. You want me to explain that? I don't know.
I promise to execute.
It seems to confuse people enough that I don't think it's good language. But also, I think it confuses people because they still want to think in their procedural scripting language method. This line of code, this line of code, this line of code. I block and wait, but I execute this line of code, this line. And that's just not how it works at all.
It's becoming more like a human, how a human thinks and reacts.
I don't know. But it is a completely different way to make your stuff work. Okay? Down to the operating system level. Does that make sense to you? Okay. That's how it works.
It's like if you're going to Wendy's, but you want the burger, but it's too expensive, then you'll get the hamburger. So it's two events that come together, and then you do this. And that's how I'm thinking of it.
Okay. Good. Let's get out of here.